Good day. This video will continue the STPM Past Year in 2021, Section B. Question 16, we have 2 point charges, negative 30 and positive 60 microcoulomb are separated by a distance of 14 centimeter. X is located 2 centimeter from the negative charge. Question A, calculate the force between the charges. So this is the electrostatic force that you have learned from the Coulomb's law, and the formula is provided here. So all the values are given. Okay, we have the charges and the distance. So you just put in the value and you can solve the first question here. So the force is equal to the product of the charges, 30 microcoulomb, multiply 60 micro, divide by 4 pi, divide by epsilon, divide by r squared. So it is a 0.14 meter squared. Okay, so the answer here is equal to negative 825.4 Newton. Okay, so the negative here reflects that the force is attraction force. Okay, it is the force between negative charge and positive charge. Okay, so move on to B, determine the magnitude and the direction of the resultant electric field at X. So you should be clear what is the kind of the electric field produced by a point charge. So for negative charge, it produces an inward direction. Okay, it produces an inward direction. So it will produce an electric field, the direction is to the left at point X, while for the positive charge, it produces upward direction. So it will produce a electric field direction to the left also at X. So now we should be clear that both the electric field due to both of the charges is to the left. Okay, they are in the same direction. So the resulting electric field here, we will need to perform the addition, and the direction is of course to the left. So the last thing is to get the magnitude, that the electric field is equal to 1/4 pi epsilon multiply Q over R squared. So we just put in the value to obtain the magnitude. So the negative sign can be ignored because here we only consider about the magnitude, and we also learned that both of them are in the same direction. So we just perform the addition, that the first is the electric field due to the negative charge. So it is a 30 micro, divide by the distance, which is 2 centimeter, okay, 0.02 squared, plus the electric field strength due to the positive charge, 60 micro, divide by the distance. So the distance is equal to, so 14 centimeter minus 2 centimeter, it is 12 centimeter, okay, 0.12 squared. Okay, so the next step is to calculate the value. So put in all the value. So we have the 30 micro, divide by 0.02 squared, plus 60 micro, divide by 0.12 squared. And then we divide by 4 pi epsilon. So the answer is equal to 7.11 times 10 to the power of 8. It is a watt per meter. So this would be the answer. So this is the magnitude, and the direction is to the left. So the next thing is to predict a possible position of a point where the resultant electric field is 0. Okay, so you have learned some diagram about this before. Okay, it is between positive charge and the negative charge. So we can see there's an electric field between the two charges, and probably there will be an electric field in the left or the right side also, if there is also another charges nearby. So for here, maybe we can just for safety, we can maybe provide the answer like above the positive charge. Okay, this is the area that there will be no electric field because the electric field is attracted to the negative charge. Okay, or maybe above the negative charge also possible, or maybe you can choose the position that is below the both of the charges. Okay, so between the charges, certainly we will have electric field, so this would not be the answer. So predict a possible positions. So 1 mark, so I think you just give a try. And we will move on to question 17. Capacitor of capacitance 10 microfarad initially is charged by a battery of potential difference 500 watt. Determine the charge in the capacitor. We have the capacitance, we have the potential difference, just apply the formula Q equal to CV. So capacitance is 10 micro, multiply the voltage 500 watt. and you obtain 5 millicoulomb. Okay, so this is what you get. Okay, 0.005 coulombs. Okay, and then the battery is then removed. So battery is removed indicates that the charge is conserved. Okay, so you should understand about this. And the capacitor is connected to an uncharged capacitor of capacitance 40 microfarad. So this question is quite similar as one of the question in the ulangan paper of 2021. Okay, so if you have watched the video, so you should be clear what to do to solve this question. So the first is to determine the potential difference across both the capacitors. So what we did is first we get the new effective capacitance. So the connection between both of the capacitors should be in parallel because the capacitance of 10 microfarad, okay, if it is connected in series, it won't be a complete circuit. So the possible connection is in parallel. So this is how you should expect about the connection of the capacitor. So to calculate the effective capacitance of the capacitors in parallel, so we just do the addition. So 10 plus 40 microfarad, and it is equal to 50 microfarad. And then we're going to utilize the steady state or the final states of the capacitor that they will perform a charge redistributions. So in the end, that what we have is the potential difference across both of the capacitor will be equal. So the final potential will be equal to the total charge over the capacitance, okay, the new effective capacitance, where we have the charge as 5 millicoulombs divided by the new capacitance, so divided by 50 microfarad. And the final answer will be equal to 100 watt. Okay, so if you don't really understand, maybe you can watch back the video or you can watch one of my video about the capacitors in series and in parallel. So we move on to the next one, calculate the total energy of both capacitors. So it is just simple that you just calculate the energy in the effective capacitance. So what we do, we just apply the effective capacitance condition that we have half, multiply the capacitance 50 micro, and then we're going to multiply the potential difference 100 watt. Okay, so just apply it. So we have 0.5 multiply 50 micro, and then we just multiply 100 square. So the final answer is 0.25 joule. Okay, energy is joule. So move on to section C. An electron moves into a uniform magnetic field. Describe the path of the electron when the direction of the motion of the electron is perpendicular or parallel to the magnetic field. So you should be clear that it should be perpendicular to the magnetic field, that there will be a magnetic force acted on the electron. So to answer this question, because it has 4 marks, so you need to carefully give all the information, as many as you can, to answer this question. So this is the sample answer. So an electron that moves into uniform magnetic field will experience magnetic force. Okay, this is for the case of the perpendicular motion. The direction can be determined using the Fleming left-hand rule. So you can use a picture to further explain about this. For example, when you have a magnetic field that is into the page, and we have the electron moving up, so what you apply is the Fleming left-hand rule to determine the direction. So please be careful that this is an electron. So the times that you have obtained the direction of the times, you need to reverse the direction as the force acting on the electron. And then what we could expect is that the magnetic force is always perpendicular to the motion of electron, which become the centripetal force that causes the electron to move in a circular motion. So, okay, so I think this will be all the points that you need to add into the explanation to get full marks. Okay, and then we're going to explain about the parallel. So besides the Fleming left-hand rule, okay, you should also learn about how we can obtain the direction by the cross product of the V and also the B. So if they are in parallel, so the product, okay, the cross product of the V and B will be equal to 0. So if the electron move in the direction parallel to magnetic field, there is no magnetic force. Hence, electron will continue to move in a straight line along the magnetic field. Okay, so if you have any idea to add into the explanation, maybe you can leave it in the comment section. And we'll move on to B. Two long parallel wires P and Q are separated by a distance of 0.303 meter. Each wires carry current of 5 and 3 ampere, as shown in the diagram. So both are flowing in upward direction. So if you apply right-hand grid rule, so you can see that the magnetic field produced by P is in anti-clockwise direction. Okay, this is for the upward direction. And for P, it will be into the page, while Q will be exit, okay, entering out of the page, So both the direction of the magnetic field is in opposite direction. Okay, the magnetic field produced by P and Q will be in opposite direction. So first is to determine the position of a point where the resultant magnetic field is 0. So first of all, you need to know the formula of the magnetic field produced by a straight conductor that is provided by the Ampere's law, and it is equal to mu I over 2 pi d. And we can see that both the magnetic field is in opposite direction. So we could expect that they are cancelling each other, that at a certain point, the resultant magnetic field is 0 if both of their magnitude is equal. So to do this, first we need to derive the expression of the magnetic field in between the wire P and wire Q. So let's assume the direction into the patch as positive, okay, into the patch as positive. So we are going to derive the magnetic flux density. So it will be equal to mu over 2 pi. Okay, so and then we're going to derive the I over D for each of the wire. So for wire P, it is equal to 5 ampere over the distance. So I have labeled the distance here. So the distance between the point and the Q will be equal to 0.03 minus D. So it will be minus, okay, we assume that entering into the patch is positive. So out of the patch should be negative. So minus 3 ampere over the distance, which is equal to 0.03 minus D. So this would be the expression of the resultant magnetic field between the wire P and wire Q. So now we're going to determine the position of a point where the resultant magnetic field is 0. So it means that when B is 0, okay, so this would be the next steps. So when B equal to 0, so what we can expect is that 5 over D is equal to 3 over 0.03 minus D. Okay, so this is where the B will be equal to 0. So now you just solve it in a mathematical way. Then you can just solve it. I think you can do it on your own. So I just proceed. So it will be equal to 0.15 minus 5D equal to 3D. And then what we have is 0.15 equal to 8D. So D is equal to 0.15 divided by 8. So you will obtain 0.019. Okay, probably you can get two significant figures. So probably you need to further explain about the direction because if you denote it correctly. So it is 0.019 meter from wire. Okay, so it will give you more accurate explanation on the direction, okay, the position of the point. Okay, so next we're going to sketch a graph of the variation of the resultant magnetic field with the distance between P and Q. So we have the formula here. So maybe you can key into the calculator and obtain all the coordinates. Or maybe we can roughly derive the graph, okay, based on the equations. So for here, okay, let me show you how we can do it. So maybe we can just ignore the constant of the mu naught or mu over 2 pi because we just need to sketch the graph. Okay, so first of all, let us see about the first graph, which is by wire P, it is equal to B equal to 5 over D. Okay, so this graph is reciprocal graph that you will obtain graph like this. Okay, so simple. Then the next one is B is equal to 3 over 0.03 minus D. So this is also reciprocal graph, but it has an asymptote at D equal to 0.03. Okay, so this is the asymptote. So expect a graph drawing in this direction. Okay, so and then what we're going to do is we're going to minus the B1 minus B2 and you will obtain the resultant magnetic field. So what we have is we're going to move this one. Okay, so we're going to have here. And then this would be equal to the distance 0.03 meter. So we just need to sketch the graph of the resultant magnetic field between wire P and wire Q, which means it's from 0 to 0.03. So for the resultant magnetic field, what we need to do is to sketch the graph between the wire P and wire Q, which is 0 from 0 to 0.03. And if we perform the B1 minus B2, so at this point, okay, should be the point where you have the zero resultant, okay, zero resultant B. So you should obtain something like this, okay. So where this point is equal to 0.019. So this should be the graph of the resultant magnetic field. Okay, and then you should do the labeling and the distance. Okay, so this should be the resultant magnetic field. And we will proceed to the next question, 19A. Explain the phenomenon of the mutual inductance, 4 marks. So you need to give a full explanation about the mutual inductance. So first of all, okay, it is a phenomenon of induced EMF in the conductor due to change in current flowing in a neighboring conductor. Okay, this is a very important keyword, neighboring conductor. When the current in the neighboring conductor change, the magnetic flux that link to the conductor also changes. Okay, based on the Faraday's law, there is induced EMF in the conductor due to the change in magnetic flux linkage. Okay, so we proceed to question B. A coil with 10 turns is wound over the middle part of a long solenoid with 1,250 turns per meter. So this is the number of turns per length. And diameter 4 centimeter as shown in the diagram. So we have the diameter and we can calculate the area. The current in the long solenoid is increased at the rate of 100 ampere per second. So the first question is to determine the magnitude of the induced EMF. And then we're going to determine the mutual inductance. So we learned about the E is equal to negative M over di dt. However, okay, we don't have the mutual inductance and it should only be solved in question number 2. So how can we solve the first question is that maybe we can start from the derivations. So that's why I'm always says that the derivation is a very important thing. We need to master it to solve a lot of questions in physics. Okay, so first of all, what we can do is we start from the Faraday's law to solve the first question. That the EMF is equal to d phi dt. Okay, d phi dt. And then, so we just need to determine the magnitude, so we can just ignore the negative sign. So what is the flux is that is equal to NBA. So here the current is changing. So what we could expect is that the magnetic flux density in the solenoid is also changing. Okay, it is also increasing. Okay, so it is equal to NA dB dt. And then what can we do next is we need to recall back what is the formula of the flux density inside the solenoid. So it should be equal to Na multiply mu Ni. Okay, so the I will be inside the dt. So this is the rate of change of current that is given in the question. So if you observe carefully, we have, okay, so if you observe carefully is that the number of turns here should reflect to in the coil, okay, should be in the coil, number of turns of coil. And then the magnetic flux density should be produced by the solenoid. So the B here, the N here should be the solenoid, and the current should be the one flowing in the solenoid. So we have the number of turns for the coil, and we have the area. We have the number of turns per length for the solenoid, so everything is there. So now we can use this formula to calculate the magnitude of the induced EMF. So maybe you can do revision again on how we can do the derivations until this step. And you're going to use this to calculate the induced EMF. So the number of turns of the coil is 10 turns. Multiply the area where you have the diameter. So area is equal to pi d squared over 4. Okay, multiply pi d squared over 4. So you should convert to meter square over 4. And then multiply mu. And then multiply ns, which is 1250. And then multiply the rate of change of current, 100. So it is equal to 1.97 milliwatt. Okay, 1.97 milliwatt. So if you know how to do the derivations, so 5 marks is yours. Simple. So now we can use the formula. Okay, we can use this formula to solve second question, determine the mutual inductance. So we have the induced EMF as a 1.97 milliwatt. Okay, so it is equal to the mutual inductance multiply the rate of change of current. So what we do is just divide 100, and that is your mutual inductance. It is equal to 1.97 times 10 to the power of negative 5 Henry. Okay, so mutual inductance has the same unit as the self-inductance, so it's Henry. So that's all for question. So we proceed to C. So a metal rod PQ of length L is spun. So spun means that it's fixed and it allowed to rotate. Okay, but its end Q at a constant angular speed omega in a uniform magnetic field B directed into the pitch. Derive an expression for the induced EMF between both ends of the rod in terms of omega, L, and B. So for here, we need to derive the induced EMF, and we also can start from the Faraday's law. So the rod is rotated. So what we can see is there's a change in area. Okay, so previously it was change in the magnetic flux density. So what we can do here is E is equal to negative dV dt. So it is equal to negative B dA dt. So next is we need to identify the area and the time. So for here, so let's say it travels a complete cycle, a complete circular path. So the area covered should be the area of a circle that is equal to pi r squared. Okay, pi r squared. So we'll use pi l squared, L as the radius of the path, divide by the period. Okay, divide by the period of the motion. And from here, we need to derive the induced EMF in terms of omega, L, and B. So we only left the omega, and you should know that omega is equal to 2 pi over T. Okay, so omega, the expression is 2 pi over T. So we're almost there. So we just put in the expression that pi over T is equal to omega over 2. So finally, in the end, that the induced EMF is equal to negative BL squared over 2T. Oh yeah, with the omega. Okay, omega BL squared over 2T. So this would be the expression of the induced EMF for this question. And second is to state which end of the rod is at higher potential. So this is about the electromagnetic induction. So you use your Fleming right-hand rule. So from here, if you apply the Fleming right-hand rule, so you should obtain the direction as in this direction. So this is an EMF. So the higher potential should be at point Q. Okay, so the point Q should have higher potential. So this is how you can determine the potential difference. Okay, so the short point Q has higher potential. Okay, so we proceed to the last question. What is meant by an alternating current? So simple, a current that reverses its direction periodically. B, a sinusoidal voltage supply, V is equal to V naught sin omega t, is connected to a capacitor. So this is a pure capacitor circuit. Derive an expression for the current through the capacitor. So simple, we can use I is equal to C dV dt. So the derivations can be obtained from the textbook. So this is the flow. So we perform the derivative, and then we can get the expression I equal to omega CV naught cos omega t. And we can replace omega CV naught as I naught, which is the peak current. And then we're going to sketch the graph, the variation of the voltage and the variation of the current. So you should understand that the current is leading for the capacitor, that the current should be, so it depends on the equation given, so it should be a cosine wave. Okay, while the voltage should be a sine wave. So from here, we can see I is leading the voltage. So the waveform here is referring to the power, but you actually don't need to draw, but it is for question number 3. So explain the average power in the capacitor. So power is equal to VI, that we have learned that power is alternating between the positive and the negative value. So to explain the average power, so maybe we need to state that the power is alternating, okay, it's changing between positive and negative value. So we have learned about the positive means that it is when the power is applied to the capacitor, and when the power is negative, it is in the reverse way, that the energy or the power is returned by the capacitor to the voltage supply. So in the end, the average power is equal to 0, which means there is no power dissipation across the capacitor. And this is also applied the same as in the inductor. Okay. So we move on to question C. The sinusoidal voltage is supplied to a capacitor and a resistor connected in series. So this is RC circuit. So determine the impedance. So simple. So we need to find the reactance and the resistance. So we have the capacitance and here is the frequency. Okay, so this should be the angular frequency, okay, omega t. So no need to find 2 pi f, okay, it's 2 pi ft. So omega is 100, so simple, just need to put in all the value. So it is equal to the square root of r squared plus the reactance of the capacitor. So reactance of the capacitor can be obtained by 1 over omega c. So it should be 1 over 100 divided by the capacitor, 100 micro. Okay, so you can write the solution yourself. So the impedance will be equal to the reactance square plus the resistance square. So resistance is 70. And then we're going to do the square root and the impedance will be equal to 122 ohm. Next, determine the maximum current. So we just apply I is equal to V over Z. Okay, V equal to IZ. So we have the voltage, peak voltage as 50 divided by the impedance. So you will get the peak current as 0.41 ampere. And then last question is to draw a phasor diagram for the voltage supply and the current in the circuit. So this is also what we have learned before. So question 20 is considered as almost quite similar as the syllabus. So we have this phasor diagram that we have learned before. So make sure you remember that voltage cross capacitor is lagging behind the current, and where the voltage cross resistor is in phase with the current. Okay, so this is standard. So the voltage supply is in this direction. Okay, so it will be lagging behind the current. Okay, so maybe you can find the phasor angle, or maybe you can just leave the answer as this. So that's all for the discussion for the past year 2021. If you have any question, you can leave it in the comment section below. Also, please share the video, and thank you for watching.